So here I am taking some questions to discuss with you. With these questions, we can revise our concepts, and along with that, if we don't know, then we will learn also, is not it? So let us begin. The first question: if R is a relation from A to B, and B are to any two sets, then four options, none of these. R is equal to A cross B, R is subset of A cross B, and then R is subset of B cross A. So to answer this question, we must know the definition of the relation. What is the definition of relation? Relation R from A to B is subset of A cross B. A cross B, cross product, and then subsets. So here option B is the correct option. Isn't it? To answer this question, we must know the definition. So from here we can revise what is the definition of a relation, isn't it? Now question number 2. If P and Q are finite sets, what is finite sets? The sets contains finite number of elements or countable number of elements. In that case, we say finite sets, right? P and Q have a countable number of elements. That's why they are finite sets. That is what here it is called. And with NP represents number of elements in the set P, which is 2, means P contains 2 elements. And then Q contains 9 elements. So how many elements are there in the cross product? That is what here asked. So the way of finding the number of elements in cross product is multiply these two numbers. We get the number of elements in a cross product of two sets multiplying the respective numbers of elements in the given sets. Okay. Here P contains 2, Q contains 9. That means the product of 2 and 9 is the number of elements in P cross Q. So that is 18. It is simple. The process you remember, then I think you will be able to answer all these type of questions. Isn't it? So now let A contains AB and B contains CD. Two elements are there. The number of relations from A to B is. This is very important question. ये बहुत ही important question है क्योंकि ये क्लास 12 में भी क्वेश्चन आता है बोर्ड एग्जाम में, इसीलिए this is not only important in class 11 but also in 12. So we must learn this. But for that, what are the required informations, right? So number of relations means first we must know the definition. What is the definition of relation? We already got it. Relation from set A to another set B is a subset. This is important point. Subset of A cross B means number of relation from A to B, and these relation are subset of A cross B, is not it? These two, cross product of these two sets. So for that we have to find out the number of subsets actually, isn't it? If a set contains P elements, then the number of subsets of the set is 2 to the power P. 2 to the power number of elements in the set. That is how we can count the number of subsets, right? So let us proceed to find the number of relations. Now given A is equal to A comma B and B is equal to C comma D, the number of relations from A to B is actually number of subsets of A cross B. That is what we understood so far. Now number of subsets of the set is 2 to the power n A cross B. That means 2 to the power, following the formula, 2 to the power P, isn't it? Now number of subsets of the set is 2 to the power NA cross NB. NA cross B means NA cross NB. This is another point to be noticed, right? Next, NA means 2 elements are there and NB 2 elements, so 2 into 2. So 2 to the power 4 is equal to 16, isn't it? This is your final answer. I think this is your option, correct option. Okay, let us proceed. Number 4. If A and B are two sets such that their cross product is 5, then out of these 4 options, which one is correct? Here, A is equal to 5 and B not equal to 5. This is one option for getting A cross B is equal to 5. Is it true? A is equal to 5, B not equal to 5. then we will get A cross B is equal to phi. That is right. But is it always true? Or is it the only way for getting A cross B is equal to phi? Isn't it? This is not the only way. There is another option is also there. A not equal to phi and B equal to phi. This is also true. But here we are asked if A and B are two sets such that A cross B is equal to phi, then which of these is correct? Isn't it? This is correct, this is correct. And A is equal to phi, B is equal to phi, then also we get A cross B is equal to phi. Isn't it? So all these options are correct for A cross B is equal to phi. And this one, this is indicating A is equal to phi and or B is equal to phi. What does this mean? This is representing all these three. So actual option is this one. You can see this means A is equal to phi or B is equal to phi. And A is equal to phi and B is equal to phi. This single statement implies all these four options. So actual correct answer is this one. Okay. Now question number 5. The number of non-empty proper subsets of a set containing n elements. Here we have to know subsets, proper subsets, and then non-empty proper subsets, right? Actually, proper subsets, which sets are called the proper subsets, isn't it? Phi and the set itself can be subsets. Okay. So here non-empty means phi is to be excluded. Now first of all, so how many subsets can we get? Here 2 to the power n subsets we can get because the set contain n elements, 2 to the power n, this one. But we are under restrictions, isn't it? One condition is the subsets must be proper. The set itself cannot be proper subset. So the set itself is rejected first. So 2 to the power n minus 1 subset will be there. And one more thing is there, the non-empty subset. Non-empty means phi is also to be rejected, isn't it? So excluding phi and this set itself, we will be left with 2 to the power n minus 2. I think this is your exact answer. Question number 6. If A and B are non-empty disjoint sets, so what is called disjoint set and what is non-empty sets? Non-empty means the set which contains some elements. Empty set means this set contains no elements, but non-empty means opposite of that, the set has some elements. And disjoint sets having no common elements, right? And any two sets are called disjoint if they have no common elements. So when A and B are, we know our A and B are non-empty disjoint sets. That means their intersection is phi. That means n A intersection B is equal to, n means number of elements in the intersection part will be 0, isn't it? So n A union B is equal to n A plus n B minus, this is 0. So for these two sets, this formula is not necessary. Out of this, which one is exact answer? So I think C, n A plus n B, this is just to be rejected, not necessary, because our sets are disjoint sets, isn't it? This intersection part is 0. So leaving this part, we will be left with this one only. So this is our correct answer. Fine. Now question number 7. If A contains these elements B, this, C, this, then A minus B cross product or B with B minus C is, we will find out this one. Now A minus B means those elements which are in A but not in B. So A minus B will contain within A but not in B. Here one first element 1, 2 is in B, isn't it? This 2 is in B and 4 is also in B. So we cannot take these two elements. 5 not necessary, because by definition A minus B means all those elements which are in A but not in B. Is that it? So here A minus B is only this element 1. Then B minus C, here all those elements which are in B but not in C. So B not in C. 2, 5 is to be rejected. So I think 4 is our required answer, is not it? Here B minus C will give the set 4, right? And then their cross product, isn't it? Let us find their cross product 1, 4. So this one or this one. Yes, there is confusion, but across B, you know, this cross it, this is actually a set. Cross product of two set is a set. It is just like an ordered pair. This is not a set, is not it? So to be a set, we need this curly bracket, is not it? So proper answer is B, not this one. Okay. Now let A equal 1, 2, 3, B equal to 4, 5. Then which of the following is true? A cross B will contain all those elements whose first component is to be taken from A, isn't it? 4 is not an element of A, so this is definitely wrong. Then 5 is from B, 2 is from A. This is a correct option. And 1, 4, 1 is from A, 4 is B. So, but B is considered as first set, so here first component must be from B, but not. So this is wrong, this is wrong, this is correct option, because 2 is from A and 5 is from B, isn't it? Now 9, if A contains A comma B, then A cross E is A, B, 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 A, B, 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 A is true or false. Choose the correct option. So before finding all A cross A, let us see how many elements will there be in A cross A. First, in A cross A, how many elements will be there? Here 2 elements are there, 2 elements are there. So A cross A will contain 4 elements. And then A cross A means here A cross A will contain 4 elements and A cross A will contain 2 elements, isn't it? Have you understood this? Here 2 elements, here again 2 elements. Now this is also 2 elements. Now these 2 will contain A cross A 4 elements, isn't it? This is 4. With this A 2, 4, all total how many elements we should have? 8, isn't it? But how many elements are given here? Only 4. So from this directly we can say that this statement is false statement, isn't it? Or you can find out all pairs. That is a long process, but I think this way is the shorter way to get your answer, is not it? Okay. Question number 10. Choose the correct option. A cross B contains this. Then A is this, B is this. Is true or false? See, we know that in a cross product of two sets, first components are from first set and second components are taken from second set. So A will contain the first components, that means 1, 1, 4, 4. So A must contain 1 and 4. So this is we are having, and second components 2, 3, 2, 3 must be in B, and this is what we should have, isn't it? So A is 1, 4, B is 2, 3 is the right statement. So this is true. Choose the correct option. Correct option is true. Okay. Now which of the following is false? A minus B is equal to A intersection B complement. A minus B, A minus A intersection B, A minus B complement, A minus B, A union B minus B. So by observing, we can say that A minus B is equal to A minus B. Is it same? Definitely B should be B, only then these two expressions will be equal. a minus b must be equal to a minus b. How can you say that b transformed to b complement? Is not it? So this is, I think, a wrong statement. Which of the following is false? This is false statement. Now the domain of the function 1 by root over 3x plus 2 is, domain means the values of x. Actually here what can be put, we have to find the values of x for what this expression is defined, isn't it? You see x is involved in the denominator and also under the root. So 3x plus 2 cannot be 0, moreover cannot be negative number. It means 3x plus 2 must be a positive number, right? That means 3x plus 2 is greater than 0. Now solve it. You will get x is greater than minus 2 by 3, is not it? Minus 2 by 3. All those values which are greater than minus 2 by 3, excluding minus 2 by 3, means observing this we will see that this is correct option. So domain of this function is this one, isn't it? Why have we considered this? This is very important because this expression, you see, this expression is denominator, so it cannot be equal to 0. That's why we are not putting here equal sign, right? And also this 3x plus 2 is under root, so it cannot be negative number. It must be a positive one. So that is why we are using only the strictly greater than symbol, right?